Hello everyone. Welcome to this video on learning mathematics through concepts and examples. In this video, we are going to learn optimization problems. Okay, here is our first example to begin with. So in this question, let's see what we are asked to find. A farmer has 2,400 feet of fencing and wants to fence off a rectangular field that borders a straight river. The farmer needs no fence along the river. What are the dimensions of the field that has the largest area? Okay, so what we can do is first we can sketch a diagram quickly. Say, for example, here is the river flowing like that. Okay, that is the river. And there is a rectangular field, and one side of the field is the river. The other three side is here. So that is the river. Okay. Now let's see the width of the river. So this one, the horizontal, we can say that's the width of the river. That's the length of the river. So width of the river, length of the river. So we have a total of 2,400 feet of fencing material. So that means if we add all these, the maximum possibility is 2,400. I'm going to consider width as X. So let's begin like that. Let width is equal to X feet. So this implies length will be equal to, you can see, if this side is X, width is X, this is also X. So the length will be total minus these two X, because the width is X, length is X, means this is X, this is X. So it is equal to total possibility, 2,400 feet minus 2X. That is the possible length. What we have to do is, we have to find the dimension, meaning we have to find the length and width of this field so that the area is maximum. So we want to maximize the area. So let's find the area in terms of X. Now area in terms of X is equal to length multiplied to width. This is the length, that is the width. We multiply. So X times negative 2X. Negative 2X squared. And then X times 2,400, that is 2,400X. So that is the function. That is the area function. We want to maximize this. So now what we can quickly do is we can find the first derivative. So the first derivative will be negative 4X plus 2,400. And what we know is the maximum or minimum value occurs when this first derivative is equal to 0. So we can say that. So area is maximum, or it can be minimum, when the first derivative is equal to 0, or meaning of that is negative 4X plus 2,400 equal to 0. So if you solve that equation, we get X equal to, okay, X equal to 600. So when X is equal to 600, we have a maximum or minimum value. But we have to verify that we have either maximum or minimum. We have to determine which one it is. So what we do is we are going to use the second derivative test. So we are going to find the second derivative test. Also, let's find the second derivative of the function. Second derivative happens to be negative 4, which is less than 0. And we know that if the second derivative is negative, there is a maximum value. So this implies, meaning of this is area, okay, area is maximum. Area is maximum when X equal to 600. So when X equal to 600, area would be maximum. Okay, we know when the area is maximum, when the width is 600. We are asked to find the dimension of the rectangle or dimension of that field. So we can say, hence area is maximum if length is equal to, length will be equal to, so you can see length is 2400 minus 2 times x. X is 600, so 2 times 600 is 1200. 2400 minus 1200 is 1200. So length equal to 1200 feet and width equal to, we already have the width. We assume it is x and we already got x. X is 600 feet. So if the length is 1200 feet and width is 600 feet, the area would be maximum. We are asked to find the dimension, that is, we are looking for length and width. So that's how we can solve this first example on optimization. Okay, let's move on to next problem. Here is our next problem. Find the dimension of a rectangle with perimeter 500 meter, whose area is largest possible. So this is quite similar to the previous problem. So we can draw our rectangle. We can draw a rectangle like this. And then assume that the length is equal to x. And let's say width is w. We'll find that. Okay. So let's begin with the length. Let length of a rectangle equal to x meters, which implies the width is equal to, so the total is 500. So if this side is x, this side is also x. And if this is w, that is also w. So if you want to find the width, that is equal to 500. You can see the total is 500 minus, we subtract this x and this x. That is 2x. We subtract that. So the remaining is divided into two parts. Or that is equal to, or that is the width, right? That is the width of the rectangle. Because if you subtract 2 length, the remaining will be the width. We divide that by 2. So this will be 125. 125 minus x. Okay, so if the length is x, the width is 125 minus x. We want to find the dimension of the rectangle with maximum area. So here also we want to maximize the area. So here area is equal to area. I can write as a function of x. What we do is we multiply length and width. So if I multiply x with x, that's a negative x, so negative x is squared. And then x with 125, that is 125x. So this is the area function. This expression gives the area. We want to maximize the area, so I need the first derivative. So this implies the first derivative is equal to negative 2x plus 125. Okay, negative 2x plus 125. Hold on, one important thing here. There is a small error that I want to point out. Over here, when you divide 500 by 2, it's not 125. 500 divided by 2 is 250. So this is 250. Okay, 250. So that means over here, there must be 250x. Okay, there must be 250x, and the derivative of 250x is 250. Okay, let me fix all that. Okay, because this is 250, so when you multiply, that is 250x, so we get that. So that is the first derivative. And what we know is the maximum or minimum value occurs when the first derivative is 0. So we can say area is maximum. Area is maximum or minimum, we don't know yet, if the first derivative is 0. Meaning of that is negative 2x plus 250 is equal to 0. And if we solve that equation, we get x equal to 125. So what you can say is area is maximum or minimum when x equal to 125. So we have to confirm this, whether it is maximum or minimum. In order to do that, we can use the second derivative test. So let's find the second derivative test. Let's use the second derivative test by using the second derivative. Now, the second derivative is equal to, if you want to find the derivative of this one, that's equal to -2, which is less than 0. Second derivative is negative. Meaning of that is area is maximum. If second derivative is negative, the function value will be maximum. Area is maximum at x equal to 125. So in this line, we said area is maximum or minimum at x equal to 125. But here we confirm that it is actually maximum at 125. So that means when the length is 125, the area is maximum. We are looking for the dimension. So let's write the dimension of the rectangle with maximum area. Hence, we say dimension of rectangle, okay, rectangle with maximum area. With maximum area is, so we got the length, that is 125 meter by the width. Width is 250 minus x. 250 minus 125, that's also 125. So that means if that is a square, 125 by 125 means a square. If this structure, this rectangle is in fact a square, then the area will be maximum. Okay, that is the second example. I think we'll do one more example in this video. So let's move on to the third example. Okay, in this one, we are asked to find a point on the line y equal to 2x that is closest to the point 1, 4. So here, let me try to sketch the graph so it is quite easy for us to understand. Okay. So I have this graphing grid here, and I'm going to draw the graph on this one. We have the line y equal to 2x. So let me try to sketch the graph. So it is a straight line passing through origin. So this is y equal to 2x. We have to find the point on this line, which is closest from the point 1, 4. So let's say 1, 4 is here. Suppose that point is 1, 4. Now, we want to find a point on this line, okay, point on this line or this graph, which is at a closest distance from 1, 4. So we want to have this distance from the point to the line, this distance from the point to the line minimum, and we want to find that point. What is that point? What is this point we need to find? So if I want to represent this point, you know that if the x coordinate is x, the y coordinate on this line will be 2x. So the point is x, 2x. We want to find this distance and minimize that. So let's first find the distance. Here, distance is equal to, we use the distance formula, which is difference in the x coordinate. So x minus 1 quantity squared plus difference in the y coordinate squared, 2x minus 4. 2x minus 4 quantity squared. Let's square it on both sides. D squared is equal to, if we square it, the square root will go away. And x minus 1 quantity squared is x minus 1 times x minus 1. And if you FOIL it, you get x squared minus 2x plus 1. Then plus, again, if we FOIL this, 2x minus 4 times 2x minus 4, that is 4x squared minus 16x plus 16. Let's call this a function f, which is equal to 4x squared plus x squared. That is a 5x squared then minus 2x minus 16x, that's minus 18x, and then plus 1 plus 16, right? That is a 17. So we want to minimize this. For the distance to be minimized, we want to minimize that. So the next step is we need to minimize the function f. So now we need to find x for which f is minimum, for which this function f is minimum. So in order to find the minimum value of the function or maximum value of the function, we find the derivative. So first derivative is equal to, that will be 10x minus 18. And we know that the maximum or minimum value of this function occurs when the first derivative is 0. But what we know is f is maximum or minimum if the first derivative, that is 10x minus 18, is equal to 0, or x equal to 9 over 5 if you solve that equation. So what we know is the value of f, or this function, in other words, the distance, is maximum or minimum when x equal to 9 over 5. So at 9 over 5, we have to find the second derivative to determine whether the function is maximum or minimum. So let's find that. Also, the second derivative is equal to, if you want to find the second derivative, you differentiate this again, you get a 10, which is greater than 0. Second derivative is positive. If the second derivative is positive, this means that f is maximum. I mean, f is minimum, right? Second derivative is positive. So function is minimum at x equal to 9 over 5. Meaning of that is, okay, this means this distance is minimum. So distance is minimum if x is equal to 9 over 5. So we know when this distance is minimum. If the value of this x is 9 over 5, the distance is minimum. So we want to find that point. So final answer would be, we can write this. The point on the line, is closest. Okay, is closest to the point, 1, 4. 1, 4 is, so you know what is that point? It's x, 2x. X is 9 over 5. X is 9 over 5. 2x will be, multiply this by 2. So when you multiply 9 over 5 by 2, 9 times 2 is 18 over 5. So the point that is closest to 1, 4 on this line is 9 over 5, 18 over 5. So this is how we can solve the optimization problem using the first and second derivative. Okay, we want to end the video here. Thank you so much for watching. I hope you find this helpful.